So 8.2 gets into how we multiply and divide rational expressions. And you should know that the word rational clues us in and tells us that we're working with fractions. Okay, so we're dealing essentially with fractions, but we're dealing with fractions made up of polynomials. And so this is going to be a little bit different. First thing we need to really talk about is how these look, what they are, and then we can actually get into some operations with them. Now, as we get going through, I want you to be thinking about what makes an expression undefined. And that undefined part, how do we show that something is undefined? That's really what I need you thinking about. Okay? Here's what a rational expression is. Write these three examples down, please. This is a rational expression. That's a rational expression. A polynomial over a polynomial. So here's an example. Pretty easy looking example. This isn't too tough. There's another example. 10 is a polynomial. It's a monomial, but it's a polynomial. And here's a third one. That bottom for that one is written in factored form, but that is still a polynomial. Okay? Now, how do we tell if they're undefined? We have to be able to show undefined. We have to remember, we cannot ever divide by 0. And so the denominator can never be 0. The values for x that make the denominator 0 force the expression to be undefined. Okay, so for example, in this first one, -2, if we substitute it in, makes that function undefined, makes the bottom denominator, makes the denominator 0. In this one, of course, we know this factors as a difference of squares. And so x cannot be -3, x cannot be +3. And this last one's already factored, so that's pretty easy. X can't be 0, x cannot be -7. Those values of x that are written there in blue, those are what makes this expression undefined. When we substitute those values for x into our denominator, it becomes 0. And because it's 0, that makes these undefined. Okay, so make sure you understand how undefined works. Okay, right now let's take some time and talk about how to simplify these beautiful, beautiful things. So the first thing we're talking about is how to simplify. And basically, to simplify, it's all about canceling. What can you cancel? So let's look at this example. And we'll take a look at this example. And we'll finish with this example. So in that first example over there that I've got up on the board, we can simplify and cancel some things, right? We could cancel what 16 divided by 8 is, and we could cancel what x to the 11th over x squared is, okay? So before we do that, though, it's important to recognize x cannot be 0 for this function, okay? Keep that in the back of your mind. Now, as we cancel, 16 over 8, 16 divided by 8, that's 2. 11x is on top, 2x is on the bottom. 11 minus 2, well, that's 2x to the 9th. So this simplifies to be 2x to the 9th, but x cannot be 0. Let's look at the next one. Now, in these next two, it gets a little bit tougher because we actually have to think about factoring this information. Okay? We have to think about how this might factor. In the numerator, the coefficient on the x squared is -1. It's going to be tough to work with. So the first thing we're going to want to factor is factor out a -1. All that does is changes the signs on everything. So I'm just changing the signs so that when I'm looking at what I'm factoring, I can see, oh, okay, now I can factor that second part. It's really easy to pick out what your GCF is, right? Because now I can pull an x out, and I'm left with x minus 3. The denominator factors as 2x minus 1 and x minus 3. If you don't see how the denominator factors like that, you have to ask for help. You have to ask if that does not make sense to you. Then, cancel, what, and go from there. Negative x over 2x minus 1. Now, how do we say what's undefined? Is it only 1/2 that makes this undefined? No. Undefined we have to determine when it's in factored form. It's when it's in factored form that we can determine what is undefined. So right here, yes, 1/2 when we plug that in makes it undefined, but we also need to note that x is 3 also makes this undefined. Okay? 1/2 and 3 are both bad values for this rational expression, right? If I put 1/2 in here, it's going to be 0. If I put 3 in here, it's going to be 0. Okay? Yes, it simplifies to this, but we need to remember what makes it undefined. Okay, let's do that last one real quick. Last one, leading coefficient looks good, leading coefficient looks good, no GCF, so I'm just going to straight up factor. Now, once again, if you don't see how this factors, then you have to make sure you ask for help. If you cannot factor that, you need to ask for help. Quadratic formula is not an option. You have to be able to factor. Then, at this point is where we should check to see what's undefined so that when we cancel and simplify, there's our answer. What values of x makes it undefined? Well, when x is equal to negative 2/3, it's undefined. That comes from right here. Solve that. What value of x makes that equal 0? Then solve this side. X cannot be positive 3/2. So just simplifying. Notice the key was to factor first. The key was to factor first and then cancel and then make sure you're aware of. Now it's not too big of a stretch to go from simplifying to multiplying, so I want to take you through that next. Multiply. So here's a fairly basic one. And you're just using what you know before, or what you know from before, how to simplify fractions, how to cancel, okay? So as we look at this, we could multiply straight across the top, right? And multiply straight across the bottom. And let's do that, because that's how we multiply fractions, is we multiply the numerators, and we multiply the denominators. And then from there we can cancel. 20 over 30, well that's 2/3. X to the 8 over x to the 5th, that's x to the 3rd. That was not so bad. Let's look at a tougher one. And I want to show you this tougher one, and I want to give you some steps with it. Because it's easy when we just have x like we have on the left. It's more difficult when we have more information. There's an example, right? I'm going to give you 4 steps. The first thing I want you to do is I want you to factor everything, right? Before the first thing we did, when we did this one, our very first step was to multiply, right? That's how we got to down here. Well, we can multiply 10x minus 40 times x plus 3, but that's going to be hard to work with and cancel, right? When we were simplifying, it was all about canceling. So I want to factor first, and then I want to look to cancel. So let's talk about how that looks. Okay, so I got 10x minus 40. Well, I see a GCF of 10, and the denominator I got an x minus 4 and an x minus 2, and then I got an x plus 3 and a 5x plus 3. Now, it says cancel. Okay, how do I cancel? Well, I see an x minus 4 and an x minus 4. I see an x plus 3 and an x plus 3. Great. Once you've canceled as much crap as you can, then it becomes time, now it's time to multiply. Now it's time to actually do the multiplication. So in the numerator, 10 times nothing there is 10. Then I got 5x minus 2. The very last step is to check it. Should more cancel? Is there a way to reduce it more? And yeah, here we do, right? We have 10 and 5. Well, 10 and 5 becomes 2 over 1 when you divide both by 5. 2 over x minus 2. Okay? 2 over x minus 2. Now, where is this undefined at? Well, it's undefined at x is not equal to 4, x is not equal to 2, x is not equal to -3. But the question didn't ask that, it just asked you to multiply. These 4 steps, factor, cancel, multiply, check, those are going to be important to you. And they're going to be especially important as you get into division 2. So let's take a look at some division. Just trying to load you up with tons of examples so you've seen options, right? The big key with dividing, division of fractions, is multiplication of the reciprocal. Division of fractions is multiplication of the reciprocal. You need to have that down. I'll show you what I mean as we go through these 2 examples. Here's your first one. And here's the second one. Aren't these fun? I love this. This is one of my favorite things to do. I know I'm crazy. Who cares? Okay, so as we look at this, now we know that division of fractions is multiplication of the reciprocal. So the very first thing we should probably do is change these to be multiplication problems. That's going to be my very first step. Look at right there. Boom. Right there, I went, okay, stupid bell. No, just kidding. But what I did is I just changed it because now it becomes a lot more like what we just did. Then I'm going to multiply. And then I'm going to look for opportunities for what can I cancel. Well, 12 over 4 is 3. I got 2x squareds left on the bottom, and I got a y on top. So my answer is 3y over x squared. Okay? Not so bad. The ones that are just x's, just monomials essentially, those are pretty easy to be honest. It's when we take that extra step and try and do ones where we have polynomials, like the one on the right, that get a little bit more difficult. So let's take a look at that one now. I want to look at the one on the right. I know it's going to be more challenging, right? The steps were factor, cancel, multiply, I got an exclamation mark right there, and check it. Can it reduce more? Okay? And so, we need to, hi Drew, what's up? So, when it's division, we almost have to add a step 0. And that is, do the reciprocal. That reciprocal step becomes important because we can't truly cancel unless we're multiplying. So we're going to add in step 0, and let's rewrite this problem as a multiplication problem. Now it becomes easy. And I shouldn't say easy, that's not a nice way of putting it. Now it becomes doable. Okay, so the next step, factor. Okay, now once again, if you don't understand how I'm getting my numbers when I'm getting my parts when I'm factoring, that's a conversation that you need to make sure you have. If you can't factor, chapter 8 might kill you. Okay, there's my GCF for that one. If I really wanted to, I could take it another step further, right? And I'm going to do that right away. I want it in fully factored form. So I'm taking it all the way down right away. And I got a difference of 2 squares in the bottom. It's important to factor because it makes the canceling so much easier. I got an x plus 3 and an x plus 3. I got a 2x plus 1 and a 2x plus 1. I got a 2x minus 1 and a 2x minus 1. Cross those things out and then multiply. 4 times x minus 4 over, only thing left in the denominator is x minus 3. How sweet is that? Like,